Hi everyone, I am Shantanu, student of IIT. So today we'll be discussing question 1 of Test-1 at data science paper. So without any delay, let's start the video. So the question says, give three commonly used statistical measures for characterizing dispersal in student feedback data, like variation in teacher quality score, lab facility ratings, peer collaboration, and effectiveness. Discuss how these measures can be computed efficiently in large student databases. So first, let's understand what dispersion is. Dispersion measures indicate the spread and the variability of student feedback scores. They help to determine if students are giving consistent ratings, which means low dispersion, or very mixed ratings, which means high dispersion. So the first method for calculating dispersion in student feedback database is standard deviation. So let's understand what is standard deviation. The standard deviation measures how far individual feedback scores tend to deviate from the average mean score. It tells us whether students responded consistently, means low standard deviation, or gave very mixed ratings, which means high standard deviation. So formula for calculating SD is square root of 1 upon n summation from I is equals to 1 to n xi minus x bar ka whole square, where xi is student feedback rating, x bar is mean of all ratings, and n is total number of ratings, and sigma stands for standard deviation. Now let's see how we can compute efficiently for large databases. For large student databases that cannot load all ratings into memory at once, computation must be done in single memory efficient pass. So the method we use is Welford's one pass algorithm. The mechanism for this algorithm is that computes the mean and variance and third standard deviation incrementally by only storing few k statistics like mean and the sum and the square of difference from current mean in memory. What are its benefits? It requires very low memory overhead and works well for streaming or real-time feedback data. Now let's move on to the second method. Second method is interquartile range. We can denote it by IQR. So the interquartile range is shows the spread of middle 50% of student ratings. It is robust measure because it removes the effect of extreme 25% high and 25% low feedback values, means outliers. So formula for calculating IQR is Q3 minus Q1, where Q1 is 25 percentile and Q3 is 75 percentile. We can see this visually. Here we can see data 3 is Q3 and data 1 is Q1. Here we have written this. We can say it Q1 as a lower quartile and Q3 as upper quartile. Now let's see how we can efficiently compute this for large databases. Exact quartile calculation requires sorting the entire data set, which is computationally expensive and slow for millions of rows. So for method, uh, the method we use is approximate quantile algorithms. Examples such as T-digest, Greenwald canvas, and summary or P-square percentile estimator. Mechanism we use is these algorithms create a compact representative summary of data, the distribution in single pass. They can estimate and with high accuracy using very small memory. What are its benefits? Provides a fast, memory efficient and reasonably accurate measure for the of the middle spread. Now let's move on to the third method, which is mean absolute deviation. So what it says, the mean absolute deviation measures the average absolute distance of each rating from central point, usually the mean or median. It is mathematically simpler and often considered more stable than the standard deviation when the feedback contains extreme values. So formula for calculating the mean absolute deviation is 1 by n summation from I is equals to 1 to n xi minus c, where xi is Each rating, C is central value, which can be mean or median, and N is total number of ratings. Efficient computation for large database here, uh, and mean absolute deviation computation can be achieved effectively using a simple two-pass approach. Pass 1, compute the central tendency, mean or median from the data set, and pass 2, scan the data set again, compute for each rating and accumulate the sum final divide on the sum by. What are its benefits? This method works well with distributed systems like MapReduce or Spark, as the two paths involve only simple and parallelizable arithmetic operation and require no sorting. So the summary for measures is standard deviation spreads about around the mean, and it is sensitive. What algorithm we use? Welford one pass algorithm. For interquartile gain, it spreads the middle 50%. It is very robust. And what method we use? Approximate quantile algorithms like T digest. And for mean absolute deviation, it calculates average absolute distance from mean median, and it is mostly robust, and it uses two pass method with distributed processing. So thank you for watching the video.